Okay, this should be a short video talking about the nth term test. So we've already talked about some known series like geometric series and the p-series and the harmonic series and the arithmetic series. Those are all ones that you should at this point have a command on when you see them, be able to recognize them, and just by looking at the right piece of the expression, you should be able to know whether it's converges or diverges. And you can also use like some combination of the p-series or geometric series, use the same test. You just say that if you recognize that both of the, if you have two p-series added together and both of them converge, then you can say that that series converges. So you should be getting good at that now. So now we're going to start working through this document that's on Canvas. It has a list of the different tests, and this video is focused on the nth term test. So one of the things I emphasized earlier is knowing the difference between the sequence and the series, because every series has a sequence that it's adding up, and you want to pay attention to the notation. So in the nth term test, it's one of the only ones that looks at the, well, it's not true, there's other ones, but it's one of the tests that actually looks at the sequence and not the series. And another thing that's unique about the nth term test is you cannot use it to prove convergence. You can only use it to prove divergence. So here's the test. It says if the limit of the sequence, notice there's no little signal notation up front. So this says it's the limit of if the limit of the sequence as n approaches infinity is not 0. That's a crossed out equal sign, which means it's not 0. Or another way to say that is if the limit of the sequence as n approaches infinity is anything other than 0, then you can conclude that the series that's associated with that sequence is divergent. Okay? So let's look at a couple examples of that. Here's one that the infinite series is, we're running from n equals 0 to infinity, and so what would this look like? This would be, for example, e to the 0 plus e to the first plus e to the second, etc., right? So if we're going to use the nth term test, we're going to ignore the series for a minute and look at the sequence that it's adding up. And when you're writing these things up, you always want to state which test you're using. So we're going to say, I'm just going to put up here nth term test, because that's what I'm going to use. So now that I'm using the nth term test, then I know, take a quick glance back over at this guy, it says to look at the limit of the sequence. Okay, so I go over here and I say, okay, I'm going to take the limit of a sub n, which in this case is e to the n, as n approaches infinity, and as n gets bigger and bigger, so e to the first, e to the second, e to the third, those terms are getting larger and larger and larger. So this thing is actually approaching infinity, isn't it? So then you ask yourself, is infinity equal to 0? No. So you're going to state that. This is not equal to 0. Therefore, the series in running from 0 to infinity of e to the n is divergent. Okay? Here's another example. Take a look at this, and we're going to use the nth term test. So I'm going to write it down. Nth term test. So immediately, since I'm doing the nth term test, that means I look at the sequence. So I'm going to take the limit of 3n squared plus n minus 2 all over n squared plus 5 as n approaches infinity. Now we have to use our pre-cal skills. Hopefully you remember that if you're looking at a situation like this, we're looking at a rational function. So we did these in pre-cal when we're talking about in behavior of rational functions. So if n is getting larger and larger, if you remember in a rational function, the highest power and top and bottom become the dominant feature. And so the n minus 2 and the 5 become insignificant as n gets larger and larger. So this thing is going to get closer and closer. Whoops. This thing is going to get closer and closer to 3. So again, since that is not equal to 0, therefore the infinite series running from 0 to infinity of 3n squared plus n minus 2 over n squared plus 5, that thing is divergent because of the nth term test. Let me show you one where it fails. Let's say we're taking this summation n running from 0 to infinity of 1 over n. This is a series that we know, that is, it's a harmonic series, or you could say it's a p series with p equal to 1. So we actually know that it diverges, but let's try to use the nth term test on it. Nth term test. So if I'm using the nth term test, I would say let's take the limit as n approaches infinity of 1 over n, and as n approaches infinity of 1 over n, this thing approaches 0, doesn't it? Right? So now this is, so remember what this says is, what the test says is that if you meet this condition, if your limit is not equal to 0, then you can make this conclusion. Notice there's no way to make a conclusion of convergence. So this doesn't say that if you don't meet this condition, then the other result. It only says that if you meet this condition, then the series is divergent. So in this case, when we end up getting 0 here, we didn't meet the first condition of the test. So therefore there's no conclusion, which means we have to use some other means. So in this case, of course, we'd say, oh my goodness, what was I thinking? That's the harmonic series, which I know is divergent. Or we could say that's a p series where p is equal to 1. Therefore, this series is divergent. Because again, we know the p-series test says that if p is greater than 1, it's convergent. If it's less than or equal to 1, it's divergent. Okay, so that's the nth term test. It's really useful if you have a divergent sequence and you can tell that this. I'm sorry, if you have a sequence that is clearly not headed towards 0, and then you can real quickly show that that the series is divergent. And you notice it doesn't take a big write-up. So this is a nice test, and it's often forgot about because it's not used that much, because usually we don't get these easy of sequences. These easy of series. So, but it's good to always keep that in mind. In fact, that you wouldn't necessarily go through the test like I did here, but it's a good idea to always just do a quick check. Can I easily tell that the sequence is not equal to 0? Because that could save you a lot of work. Because a lot of these, there's other ways to prove them convergent or divergent, but it'd be a much more involved test. So, all right.